This thing that can fit in your hand shines so brightly it can be seen from space. In fact, you wouldn't ever know you saw it because you would be immediately blinded permanently, even if you were facing the other way. This is Ampharos, the light Pokémon, and the light from its tail can outshine an entire city. Is this truly possible? If so, are there any consequences of something so small releasing so much light? According to the Pokédex, the tips of Ampharos' tails shine so brightly that they can be seen from space. As a result, lighthouse keepers often use Ampharos to guide those who are lost at sea in the dark. However, Ampharos normally keep their tail tips off because it may reveal their presence to potential predators. Despite this, their powerful flash can stun both predators and prey, giving them time to flee or deliver the coup de grace. This could explain why the species evolved such an unremarkable gait and running speed. Due to its fabled draconic ancestry, it is believed that Ampharos can match the luminosity of a star using the energy of mega evolution. How do animals produce light? Is there a limit to how bright something can be? Is there more to light than meets the eye? No pun intended. This creature needs no introduction. It is probably the most well-known user of bioluminescence, a phenomenon that allows organisms to release energy as light instead of heat. Certain organisms on Earth use a molecule called luciferin to release light, such as these fireflies. Fireflies, which are technically beetles, use light to communicate by flashing in a unique rhythm. When luciferin reacts with oxygen in the presence of the catalyst luciferase, visible light is produced. Special cells regulate the flow of oxygen, allowing for exquisitely precise control of when the light is switched on or off. The efficiency of this natural process is phenomenal. An incandescent light bulb, for instance, might only transfer 10% of its energy into useful light. Meanwhile, the fireflies might transfer up to 90% of their energy into useful light, wasting only 10%. Another example of a creature using bioluminescence is the anglerfish. Although, just like with the firefly, there is a prevalent misconception regarding the anglerfish. They do not produce their own light. Rather, they farm glowing bacteria inside a special pouch called the esker at the end of their head rod. Unlike the firefly, these bacteria do not turn off. This is a symbiotic relationship in which the bacteria help the anglerfish to lure fish into their gaping mouths with light, thereby providing the bacteria with readily available nutrition. A final example is the dinoflagellates, which turned entire coastlines an electric blue. If you ever saw something like this and decided to see what would happen if you stepped on that zero glow, you would find that they would flash like lightning on the water. As a result, it would appear they evolved their lightning as a kind of burglar alarm. If something provoked them, they would glow to alert large predators, which would then consume the perpetrator. Our first reality check is straightforward. Animals develop the ability to illuminate for a variety of reasons. I'm limiting this to illumination in the visible part of the electromagnetic spectrum, which is just a technical way to refer to the light that allows us to see. Luciferins can cause yellowish green light, blue light, or even red light to be emitted, depending on the specific chemical. Even if all the fireflies in the world were gathered in one place, they wouldn't be seen from space. The brightest known bioluminescent animal, a tropical click beetle, can emit light roughly as bright as a single LED flashlight. If something glows, it means it is emitting radiation, which is quantifiable. The more radiation emitted per second, the greater the power of the source. However, consider how bright the sun is in summer compared to in winter. In the summer, the Earth is tilted closer to the sun, so it looks brighter. However, the sun doesn't change its brightness over the course of the year. This is why scientists use a measure of absolute light power called luminosity. The sun's luminosity is about 3.8 times 10 to the power of 26 watts. This is how stars are compared directly. However, Ampharos is not a star and isn't aiming to be one. It is far easier for a light source to be observed at night in the absence of other lights because the contrast would be greater. According to the inverse square law, the brightness falls with the distance squared. Imagine a bright lamp glowing in a dark field. Stand 1 meter away and it might look dazzling. Now walk back to 2 meters. You might expect it to be about half as bright, but it's actually a quarter as bright, 25%. That's because 1 divided by 2 squared is 25%. Let's assume the lower limit of Ampharos' power and say that the ability to detect Ampharos' glow from space starts at the low Earth orbit, 400,000 meters or 250 miles away from the surface. In that case, the light from their tails would be 160 billion times dimmer. In other words, to be seen with the same comforting brightness as a ceiling light but from space, Ampharos would need to be 160 billion times brighter than a household light. The most powerful flash ever created was built at Sandia National Laboratories in New Mexico and was called the Z Machine. For a few billionths of a second, the light output reached around 200 to 300 billion watts, concentrated into a space smaller than a coin. If Ampharos could hold this much power in short bursts, they could certainly be seen from low Earth orbit and possibly even further with special equipment. Our next reality check is illuminating. Pun definitely intended. It is physically possible for a phenomenon to give rise to such tremendous power yields, even if only for the tiniest fraction of a second. Light is energy. Energy is everywhere. Energy is everything. You are energy. I digress. Suppose Ampharos were 100 billion times more powerful than the lights in your house. Immediate blindness would be the least of your concerns. Now, if Ampharos could only sustain a level of power for a microsecond, a millionth of a second, the consequences wouldn't be that devastating. Later, I will explore what would happen if Ampharos could shine with the same intensity for an indefinite length of time, as might be the case thanks to mega evolution. Every photon of light contains a packet of energy that only depends on its frequency. The higher the frequency of light, the more energy it has. Blue light has a higher frequency, so a higher energy than red light. This is why it was almost impossible to make a blue LED. Consider that I've only talked about visible light, but UV rays, X-rays, and gamma rays are also forms of light with energy so high they can literally knock electrons out of the atoms and molecules therein. This might sound innocuous, but if DNA is one of those molecules, it can lead to nasty mutations, cancer, or simply death from radiation poisoning. If Ampharos' output could only be sustained for a microsecond though, that would equate to 100,000 joules, which is still enough to cause retinal injury and superficial flash burns. Still, we have only begun to describe the extent of the power of Ampharos' tail, but let's finish first our final reality check. Light can do much more than just provide us with sight. If the most nature could achieve is about the same brightness as a 10-watt light bulb, how is Ampharos a billion times brighter? What if Ampharos did not need to be billions of times brighter? Note that the reason cities are observable from space is because a city is not a point source like Ampharos' tail tip. It's an extended carpet of light spread over tens to hundreds of square kilometers. Even if each individual light is unimpressive from orbit, the sum can be very obvious. That's exactly why astronaut photography and nightlight satellite imagery can trace urban boundaries so clearly. Also, the images are normally taken with long exposures to amplify the brightness of what would ordinarily be a faint glow. Let us assume that an astronaut in a low Earth orbit of 400 kilometers above the Earth is looking down at Ampharos' tail tip in perfect darkness, with no atmospheric scattering and a black background. In that case, the threshold of visibility is basically the same as seeing a very faint star. A standard benchmark for naked eye visibility under excellent dark skies is an intensity or irradiance of 10 to the power of -10 watts per meter squared. Using the equation for irradiance, we would discover that Ampharos' tail tips would only need to be about 200 watts. This is still much higher than bioluminescent bugs, but it is much lower than what we calculated before. How? What was the point of all that then? We just calculated the lowest possible value for the tail tips to be on the verge of visibility from 400 kilometers away. Plus, that's only if the Ampharos is standing in the middle of nowhere on a perfectly cloudless night. If you want Ampharos to shine with the same luster as a ceiling light 1 meter above your face, then you need to amplify the power to extraordinary heights. Several animals store electrical energy in specialized cells called electrocytes. Electric eels, for example, build up voltage across these specialized cells and then dump it in a rapid pulse to stun prey. Ampharos could be doing something similar, except instead of sending the discharge through water or muscle, they channel it into their tail tips designed to emit light. Inside their tail tips, for instance, layers of conductive materials could accumulate separated charges, just like the plates of a capacitor. Over seconds or minutes, or even an entire day, Ampharos builds up a large electrical potential using metabolism. This costs energy, but it happens gradually. When Ampharos wants light, it allows that stored charge to rush through a narrow region of gas-like plasma or luminescent material. As the current surges, electrons collide with atoms, exciting them. When those atoms relax, they emit photons of light. This is exactly how neon lights, lightning, auroras, plasma globes, and even bioluminescent animals glow. I was just gonna ask if dimmable light bulbs work in the same way. Kind of. They work simply by controlling how much electrical energy flows into the light source at each second. Think of it like turning a tap, rather than filling a bucket and throwing that water all at once. This single bucket system naturally explains the enormous brightness range. When Ampharos release bits of energy, the power output might be tens or hundreds of watts, enough to act like a lantern, lighthouse, or faint beacon visible from orbit in perfect darkness. When they dump the charge collected over the course of an entire day, in just a few microseconds, the instantaneous power can jump to millions or billions of watts, producing a lightning-like flare that blinds, heats air, and possibly crackles with thunder. The total energy might still be the same from day to day. The difference is the speed of delivery. That's the trick. Brightness is about how fast energy flows, not just how much exists. I understand. Ampharos can switch their tails on or off like a little light switch, and even have to remember to switch their tails off when they go to sleep. You're quite right. Naturally, this would just be a slow, weak pulse entrained to the brainwaves of sleep. Are Mega Ampharos any different? Alright, are you ready for some fun? At 160 billion watts, Mega Ampharos will be comparable to the output of dozens of power stations running simultaneously, sustained as radiant output. This would deliver a punishing energy flux to the environment. In short, it would be millions of times stronger than the midday sun. Air would heat up so quickly it would expand violently, driving intense winds and shockwaves. You'd get a persistent, roaring convection column like a self-sustaining blast furnace plume. Many materials would ignite simply from radiative heating. If the spectrum includes significant ultraviolet light, you also get photochemical effects, ozone formation and nitrogen oxide, and biological harm even at distances where heating is less immediate. Within a radius of 100 meters, water would boil, skin would burn instantly, and combustible structures would ignite. The environment around Mega Ampharos becomes an expanding hazard zone of heat, glare, and atmospheric disturbance. If you were warned of blindness from staring at an object 150 million kilometers away or 93 million miles away, how much more likely would you be blinded by something millions of times brighter? The only way to shine like a star that we know of is through nuclear fusion. Mega Ampharos likely awakens its draconic genes to magnetically confine a plasma in its body, like a tokamak, a kind of experimental nuclear fusion reactor. I feel like a superconducting fluid that's close to absolute zero flows rapidly inside Mega Ampharos through special vessels that bathe their body cells like the lymph nodes in humans. Much less than a gram of plasma would need to be thrust into its tail tip every second to release enough energy to sustain star-like luminosity. Wait, but if the sun is 3.8 times 10 to the 26 watts, how come we aren't cooked? Of course, remember that the sun is 150 million kilometers away. That energy is spread over a sphere with a radius of 150 million kilometers before it makes it to us. As a result, we only intercept a billionth of the sun's energy. Okay, that's still 10 to the 17 watts. Well, when you recall that this energy is spread over the entire surface of the Earth, that only equates to about 10 100-watt bulbs in 1 square meter if the sun is directly overhead and there are no clouds in the sky. Okay, so what about Ampharos then? If you imagine Ampharos' tail tip as a star compressed into the size of a coin, the heat generated would be astronomical. Even if it were bioluminescence, 10% of wasted energy, as heat would still equate to billions of joules every second. For comparison, a powerful lightning bolt briefly carries on the order of 1 billion joules of energy. For like a couple of milliseconds, maybe even less than that. Well, you've just admitted that through mega evolution, Ampharos might be able to pump out billions of joules per second whenever it wants. Okay, to be honest, I was possibly exaggerating. Would Ampharos really have a nuclear reactor in its body? Admittedly, what is more likely is simply that Mega Ampharos is able to produce a pulse that is maybe 5 times as bright and maybe can last 5 times as long. So 25 times more powerful. This is just speculation. There is no reliable data on the extent of Mega Ampharos' power. Perhaps they are able to fuse nuclei in their bodies. Who knows what latent power lurks within the blood of dragons? Yeah, who knows? All I know is I wouldn't be getting more powerful just sitting here. Oh, okay. The legendary tail tip has also been known as Dragon's Bulb, Pearl of Ampharos, and the Unseeing Eye, due to its ability to cause immediate blindness in anyone who dares to observe its flash. As a result, some people believe it unlocks the secrets of the universe or can bestow knowledge of the future. Despite it recently becoming illegal, millions of people around the world continue to trade herbal infusions containing ground dragon's bulb and other products for unimaginably high prices. Poaching has nearly driven Ampharos to extinction, and their numbers have declined by as much as 99.7% since records began. Although scientific studies have emphatically disproven the purported remedial effects of Dragon's Bulb, the illegal trade of Dragon's Bulb products has only declined by about 60% of what it was in its peak. Of course, Mega Ampharos has more of these bulbs decorated on its tail. Moreover, the downy wool it produces can also be harvested to make the most expensive natural fabric known to man. Indeed, one of the 500 most successful companies in the world capitalizes on the selling of clothes made of this fabric, known as Quicksilk. Quicksilk can be legally marketed since Mega Ampharos can grow back its wool. Also, keeping Ampharos in their Mega Evolved state does not deplete their energy or cause intense suffering like it does with most of the Mega Evolved Pokemon. Many brands try to sell Mareep and Fluffy Wool as Quicksilk, which has inadvertently increased the populations of the wool Pokemon. Ampharos can light up the world with nothing but the tip of their tail. I may refer to it as Dragon's Bulb, but despite it being much smaller than a typical light bulb, it can flash as brightly as the sun. Perhaps it is due to their dragon's blood and genetic code that their tail alone can be this powerful. A tail, let's not forget, that is no bigger than a pearl. Speaking of pearls,